Founded in Killarney in 1958, Liebherr Ireland was the first Liebherr factory located outside of Germany. Initially, the factory manufactured tower cranes for the UK and American market, but in the late 60s and early 70s, in line with the growth of containerization, Liebherr started to manufacture rail-mounted container cranes for the intermodal terminals. In 1972, Liebherr Ireland became Liebherr Container Cranes Limited and is solely responsible within the Liebherr Group for the design and manufacture of container handling cranes. Today, Liebherr Container Cranes manufactures ship-to-shore container cranes which load and unload container vessels, rubber-tired gantry cranes which are used in the container yard to stack and load containers onto trucks, and rail-mounted gantry cranes which are typically used over rails to load and unload containers from train to stack. Liebherr is one of the leading manufacturers of container cranes globally and is known as a quality manufacturer with a premium product. To date, we have supplied over 1,000 container handling cranes worldwide. Our customers are loyal, and repeat business is a key element of our success. However, in order to retain customers and indeed win new business, we need to lead the field in terms of product development and innovation. The market for container cranes is driven by consumer demand. More goods at a cheaper price, available instantly or at the click of a mouse or the touch of a screen. The subsequent pressure on supply chains has resulted in a continuous push by port and terminals for speed, productivity and efficiency. This in turn has led to an exponential growth in container vessel sizes over the past 15 or 20 years and the subsequent growth in crane sizes. Driver aids, from simple container tracking systems to electronic anti-sway, have now become standard, and sophisticated automation systems are requested on most cranes. In parallel, operators are squeezing their operations, looking for an edge, eliminating bottlenecks, boosting efficiency, and reducing operating and running costs as the drive for cheaper goods intensifies. A focus on lifetime costs has come to the fore. Maintenance and spare parts are becoming critical as operators strive to eliminate downtime and reduce costs further. Along with automation, remote access, predictive maintenance, and data analytics are some of the topics of interest. Liebherr Container Cranes have always had a strong working relationship with Munster Technological University. For many years, we have worked together on our apprentice program, and more recently, we have worked with Joe's Lero team on projects that allow us to maintain our position as one of the leading container crane manufacturers. Having world-class expertise on our doorstep has proven to be a real benefit for us. Currently, we collaborate on 5 different research strands that bring added value to our products. In summary, the projects allow us to improve our automation systems, bring on stream predictive maintenance tools, and develop analytic tools through the use of simulation and digital twinning. The 5 strands of research are data analytics, machine learning, sensor technology and sensor fusion, simulation, and crane digital twin. The data analytics strand of research consists of the development of analytic tools and programs for extracting performance metrics and KPIs from time traces of crane operating variables. This will lead to better on-site operational decision-making as well as feeding back into crane design. Data analytics will also be employed to characterize driver paths from data trace files, for input into training sets, and for machine learning applications. One of the aims of the machine learning project is to develop a machine learning algorithm capable of determining the complete spreader path of an SDS crane to load and unload a container on and off a vessel. In addition to just specifying the optimum path, the algorithm will allow for real-time path adjustment to avoid obstacles and to correct for sway. The path adjustment will be achieved via a system of sensors which will provide inputs relating to the surrounding environment. Machine learning is also employed to develop predictive maintenance tools for crane components and systems. Work in sensor technology and sensor fusion is an accompanying stream of research for our machine learning and data analytics. Here we review and test various sensor technologies such as stereo vision, cameras, LiDAR and radar under real-world operating conditions, including factors such as weather, lighting condition and sensor diagnostics performance, with a view to improving our automation algorithms. We are currently working together to develop a crane duty cycle simulator that allows us to calculate at design tender stage how changes to crane specification or operating conditions will impact real-world operations in terms of productivity and running costs. Research into further enhancement of existing crane digital twin models continues, including the integration of more accurate structural models and control modules with the cyber, physical systems and components. Digital twin models can be used as standalone design lead tools, as learning environments for training machine learning algorithms, or integrated in our existing crane PLC test benches for hardware in the loop testing and software commissioning. Whilst the principle of container handling is still very simple, moving a box from point A to point B, the methodology and the tools used to move that box have become ever more complex. Now we need to move that box faster, greener, cheaper, and in a more predictable manner with minimum human intervention. This is where technology finds a home. This is where collaborations between industries and research-based centers of excellence can thrive. This is where Liebherr and Libra will continue to lead the field in innovation and continue to push at the boundaries in the quest to deliver exceptional products worthy of the Liebherr name.